Okay, fellow statisticians, we're looking at example number 5 here, estimation, and so here we go. Basically, we're estimating the percentage of Americans that have a fear of flying, basically, all right? So anyway, here's the point of this. It says find a 94% confidence interval. We're finding a confidence interval here. So once again, that's the easier one. That's just, if you're finding a confidence interval, there's your formula. So p hat plus or minus z alpha over 2 square root p hat q hat over n. All right? I want to remind you that p hat is the symbol we use for a percentage obtained from a sample. Right? Okay. So we go back and read this question. I guess we'll leave the p hat on until we get to the next hat here. So when you read the narrative, you hopefully realize that it says, oh, you know what? In a survey of 1,200 adults, 6.5% have a fear of flying. You know what? That wasn't reported to us in a fraction form. It was just already 6.5%, 0.065. All right? So sometimes they'll just give it to you. And then 1 minus that would be the Q hat, wouldn't it? All right? And that's going to be what? 0.935. Is that what that is? I think so. All right. So there we've got those. It's a matter of plugging numbers in, right? We're jamming. We jam the numbers in now. So p hat is 0.065. I always save that z-score for dessert. So p hat is 0.065 and q hat is 0.935. I need somebody to make a q hat for me. Why don't you guys get to work on that? Somebody make me a Q hat, all right? And it says up here that they sampled 1,200 adults. So that's the sample size. So I hope we've developed the ability to recognize that the z-score that's in these confidence interval questions is always going to be related to a bell curve with 0 in the middle and the level of confidence that the researcher wishes to have, 94%. And again, and it's kind of built in here, right? Divide it by 2. So we're going to divide that by 2. I'll be honest with you, technically 94% isn't the alpha, but hey, look, it behaves the same way. You're going to cut it in half. So 94 cut in half is 47%. And 47%, right, half of it, it's symmetrical, cut it in half. I'm afraid my p hat's about to fall off, but that's okay. And we have a couple of middle slivers here, don't we? And this table loves middle slivers, 47%, right? Table love middle sliver, good, we can change hats now. Table love middle sliver, 47%. So really, once again, we cut it in half. Table time. 47% is the middle sliver, and 46.99 is real close. Looks like that's 1.88. And again, it's very difficult. Obviously, I would think for you to see that on the video, that you have one in front of you. We've been practicing that quite a bit. So the 1.88 goes in for z, and keep in mind that the plus and minus is baked into this. So that's our margin of error. I'll take you one more step here, maybe a couple, all right? So look, this is just arithmetic. Do what's in here. So 0.065 times 0.935 equals, divided by 1,200 equals, and then take the square root of that previous answer, equals, and then take it times 1.88. Notice I'm saying equals every time. Yes, if you know what you're doing, you can indeed do it all in one step. The vast majority of people have trouble when they try to do that. Okay? I'm just a realist here. So, multiply equals, divide equals, square root equals, times. That's the best suggestion I can give you. So it looks like that margin of error is right along the lines of 1.34%. Okay, so here again, something's bothering me here. Let me try that again. I might have written that down wrong. 0.065 times 0.935 equals, divided by 1200 equals, square root equals, times 1.88. Yeah, I had that wrong. No, I didn't. 0.0134. Okay, yeah, that's good. So when you subtract that margin of error from here, you'll get your lower end of your estimate. Apparently, I took that there. Again, I won't make a big deal about how many decimals you guys keep, okay? So anyway, if you subtract that, it's here. If you add that, it's here. Lower, upper. And then again, let's get used to putting the fact that we use 94% to develop this. That's usually, in my opinion, underreported element of this. People typically don't give you the level of confidence. So anyway, 94% confidence interval, basically between 5.2% and 7.8%. Yippee-ki-yay! All right, I think we'll do one more of these and then we're going to move on.